Today we are going to discuss the second part of the periodic table, that is the periodic properties of the elements. Now before we are going to discuss about the changes in the periodic properties along a period and down a group, we have to know about certain periodic characteristics. So first periodic property or characteristics is the atomic radius. As the name suggests, radius of an atom is called atomic radius. That is, the distance from the nucleus to the outermost orbit of any atom is called its atomic radius. This atomic radius is sometimes it is also called atomic size. Now if we move along a period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, atomic radius decreases due to the increase in the charge in the nucleus and in the outermost orbits. And if we move down a group, atomic radius increases because of the increase in the number of orbits. That means hydrogen, lithium, sodium. Sodium has the maximum atomic radius among hydrogen, lithium and sodium. Now our second periodic property is the metallic nature. As we know, what is a metal? A metal is a substance which can donate electron to form plus charge or cations. If we move along a period, metallic character decreases, and if we down a group, then metallic character increases. That is, if we move along the third period, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, metallic character decreases. That means chlorine is the least metal in nature. Whereas if we move down a group, hydrogen, lithium, sodium, potassium, then potassium is the maximum metallic characteristics. Now third periodic property is our non-metallic character, that is just the opposite of the metallic character. That is, non-metallic character is the property by which any element can accept electron to form minus ion or anion. If we move along a period, non-metallic nature or character increases, and if we move down a group, non-metallic character decreases. Next, our fourth periodic property is the electronegativity. So the word electronegativity suggests that it is the property to attract a shared pair of electrons towards the atom. If we go through the structure of ammonia, nitrogen is the central atom. It contains a pair of lone pair electrons, and other shared paired electrons are shared between the central nitrogen atom and 3 hydrogen atoms. Now nitrogen being more electronegative than hydrogen, this bond shared paired electron, it will attract by the nitrogen towards the central atom, so that these hydrogens and nitrogen, they will have a charge in them. If we move along a period, electronegativity increases, and if we move down a group, electronegativity decreases. Now our next periodic property is electron affinity. Suppose the condition where you are having a gaseous element and you are told to make it anion. Then what you have to do? You have to add electrons to that gaseous atom so that it will form anions. Now to give or to add electrons to the outermost cell of the orbit, you have to provide some amount of energy. That amount of energy you have to provide to add an extra electron to the outermost orbit of any gaseous element is called electron affinity. If we move along a group, then the electron affinity decreases, and if we move along a period, electron affinity increases. That means sodium, magnesium, aluminium, silicon has the maximum electron affinity, and hydrogen, lithium, sodium, potassium has the least electron affinity. This electron affinity depends on two factors: atomic size and the net charge on the atom. Our last periodic property is ionization potential. It is just the opposite of the electron affinity. In electron affinity, you have to add electron to the outermost orbit, and in ionization potential, you have to remove one electron from the outermost orbit of any gaseous element to make it cations or positively charged ion. Now to remove that electron, again you have to give certain amount of energy. So that amount of energy which you have to give or which you have to supply to make the gaseous atom as cation is called its ionization potential. If we move along a period, ionization potential increases, and if we move down a group, ionization potential decreases. And this ionization potential also depends on those atomic size and the net charges.